This is Mischief Managed. Welcome, everybody. My name's Joe Lucas. I recently learned that there is a Joseph Lucas who's known as the Prince of Darkness. I'll say, despite my affinity for dark mode, you can see here, I am not that guy, but you're welcome to Google him. There's a link there that has all my social media if you'd like to get in contact after the talk. And I'm currently a senior AI security researcher at NVIDIA, part of an AI red team. And so we're a component of the standard red team, and we focus on the security of AI products and systems. And part of our focus there is operating kind of against internal developers, and that means we're in Jupyter environments a lot. And so I'd like to kind of just present some things for you to think about while you're working in Jupyter environments. I'll say that nothing here is new. These are not 0 days. They're the tool, the way it is kind of meant to be used. They're just kind of abuses or misconfigurations or configuration options. And so this presentation is about increasing awareness, thinking about helping you think about what you should think about every day, not generating kind of fear, uncertainty, or doubt. And I'll say the teams involved with Jupyter and IPython development, I think are fantastic. There are a lot of security options and I think very sane defaults that balance the risks we'll talk about in this presentation against kind of user experience so that you can still have a very agile research and development environment. So why, as an attacker, do I get excited when I see JupyterLab running on a system? Well, because it's a code execution platform, and as attackers are moving through networks, code execution enables them to really achieve their objectives. It's kind of a key thing they're looking for, and so Jupyter, and especially JupyterLab, provides that for me. And there are often a ton of libraries and different Conda environments, and that makes it easy to do what attackers call live off the land, where we don't have to install or bring additional tools onto the host, which increases our chances of getting caught. We can just use what's already there. So we can search through Conda environments to find libraries that you've already installed on your system that make our objectives easier. Jupyter and JupyterLab are normally networked. And so as a red team moves through an operation, we're often pivoting between hosts. And the networked position of Jupyter makes it easier to do that. And Jupyter hosts often contain keys and secrets that make it that enable that pivoting around the network. I also see frequently, when you read tutorials online, and I'll even do it sometimes too, this instinct to run all. And what you're really doing there is running a whole bunch of code that you may not have verified since the last time you ran it. So if someone modified that file on disk or modified some of the dependencies and you're using auto reload, those sorts of things, you can kind of trigger code execution for us when you do run all. And then the setup of JupyterLab, where it has this client server model, you're typing some code in a browser that gets shipped off either to a local kernel or to a remote server. It's kind of improves our stealth because the developer normally doesn't have a lot of visibility into where and how and what code is being run. They just have this very sleek environment. And again, that leads to a great user experience, but does provide some opportunities for an attacker to inject themselves in code flow. And so while I go through this talk, you should pay attention or think about how much attention do you pay to your environment. So when you run JupyterLab, do you kind of look through all those messages that scroll through before your browser auto launches or before you click on the URL and token? Would you notice if there was a new extension running? Would you notice if there were additional commands in your Jupyter history, or do you really think about your Jupyter history? And just overall increasing that awareness of your environment, of when something has changed or might not be the way you intended, is my goal here. And so think about, how do you run Jupyter? I think if you look through help, you'll see that there's this allow root flag. You shouldn't be launching Jupyter from root. I would say in 99% of the instances, I think there are very few, which is why the team kind of forces you to use this flag. So if you find yourself using that flag and launching it as root, consider that an anti-pattern. What directory are you launching Jupyter from? So Jupyter has this upward directory traversal prevention, right? I'm in a directory here, but I can't go up further to interact with things that maybe I shouldn't have access to. And while the UI does that pretty nicely, we can see, we're currently in this PyData directory. It is relatively trivial for an attacker or kind of a non-conventional flow to move upwards in the directory and impact those files. And so kind of a repeated theme you'll see in this talk is anything that can happen in a terminal or an attacker can do in a terminal, they can do through your Jupyter instance because it is so powerful and expressive. By default, JupyterLab is going to launch as HTTP because that requires very little configuration and is easy to get running. Again, great developer experience. But that means your traffic is not encrypted through HTTPS. Now, there is documentation about how you could set up certificates and do HTTPS traffic. And so if you're kind of operating in a model where you're traversing untrusted networks, or you think that you would prefer for that traffic to be encrypted, or maybe there's a requirement that it's encrypted, you should make sure that configuration exists. When you launch your instance, JupyterLab, you may end up clicking on, localhost 8888 and a long string of characters, or your browser may auto launch for you. And it uses a token to authenticate by default. And you may also have a password enabled, which would be great. But you should know that token is just used to get a cookie to get saved in your browser. And that cookie is good for 30 days. So if you open JupyterLab in this browser here, and then go away, launch JupyterLab again, you could open the browser to localhost 8888 if it's the same port, and not give a token, and you'll successfully enter your instance or authenticate because it's using the cookie in the browser to authenticate. And so I wouldn't over rely on that token to protect you or act as an authorization mechanism. And then by default, the file explorer over here does not show hidden files, but just as we ran use the exclamation point to run shell commands, you could run a shell command to show you hidden files if you needed to. So now we'll step into a modified scikit-learn example where we'll kind of talk about the normal data science process and then maybe some potential trouble areas or things you should think about as you're working through that. Right, so normally we're going to kind of have a cell where we import all of our helpful functions and modules. And a lot of times you'll see some sort of utility for authenticating with a remote service and getting something. So this could be, in this case, these are just mock functions to get something from S3. So you could think about data stores, databases. There's also often remote logging or MLOps infrastructure. So you think about ML flow, weights and biases, things like that. So we'll define a function to make this remote connection with a key and then get our data. And we'll specify a bucket. So in this case, again, we're pretending to go out to an S3 bucket and get some data. But to get to a bucket, ideally, you have to authenticate through AWS. And so here, we see that we're providing what we call a plain text credential. And so that means that in our code here, the password is human readable. And that's less than ideal because there are a couple of different ways other people can recover it and then use it to authenticate against the service as us. So let's fast forward into the workflow and think about, eventually we want to check this notebook into GitHub to collaborate with our partners. Well, if you check it in now, this password, this AWS key, secret key, is going to be in GitHub where it could potentially be recovered by an attacker. And even if you delete the file eventually, it'll be in the Git history. So there are security tools like TruffleHog that recover these sorts of things from history, and attackers are going to look for them and try and use them. So you might say, the next best thing would be to run this and then maybe just delete this string from the notebook or delete this cell and then check it in. We'll show you that does not solve your problem later on. Another common pattern I see is people using environment variables. And I think that's a step better, but if someone is on the host, they can run a shell command and see all the environment variables. So again, you need to kind of think about what your threat model is, but if you are working in kind of a very controlled kind of security critical space, instead you should be using some sort of secrets manager where you make an API call, manually enter your password and probably your two-factor authentication code, and then it returns the secret to you as a variable. Okay, and so, we move through our workflow, we generate some cool looking data, and then, maybe we load some artifacts. So we'll assume that, I have a friend and they built this logistic regression model, sent it to me as a pickle, and I want to load it. Well, there's been a lot of research done about the security of pickles, but by executing this cell right now, I potentially gave someone code execution. If they modified that pickle file, it could have already performed some action before I've really done anything else to interact with it. Trail of Bits has a great blog on this and has built some tooling around it. My colleague at NVIDIA, John Irwin, gave a DEF CON talk about it last year. So this is something you should be aware of. I think pickles are really user-friendly and powerful because they require less overhead than other serialization formats. It kind of just works, but that comes with this risk. And you might say to yourself, well, this is a scikit-learn example, and scikit-learn recommends JobLib, so I'll use that instead. Well, JobLib, under the hood as a serialization format, relies on pickle, so you really haven't avoided this. You have saved some space, and I think that's a great recommendation, but you haven't avoided kind of the underlying problem of using pickle as a serialization format. So now we'll step through, do some more data science stuff. We're comparing some models. Pretty cool. And now it comes time to save our artifact. So we're gonna, again, save this model as a pickle. And you should think here, what am I saving along with this pickle? What kind of descriptive information that allows me to verify its integrity before I or somebody else loads it? And so example here would be hashing it. You could take an MD5 hash of this pickle, save it somewhere safe, and then later on, before loading the pickle, compare the hash. And if those hashes match, it has probably not been tampered with and it's safe to load. There's also signatures, it would be another way to do this. And then let's use utility and write this to our remote bucket. Okay, let's work through some other examples here. So I have been in instances where I am operating on a host. We kind of got onto that host some other way, maybe default SSH credentials or some sort of exploitation. And I see through netstat that port 8888 is listening. So it's Jupyter, and I want to connect to it, but I need the token. So how would I do that? We have a way to get these tokens. Let me switch here. All right, well, dependencies happen. Let's see if we can run it from in here. Yeah, here we go. So, I'd run that in the terminal remotely, and here's the token. In this case, the server's listening on localhost, but often in like a collaborative environment, you'll see it running, uh, accepting kind of wildcard or remote connections, and this would allow me to connect to either of these instances that I choose. We talked about history. So remember this secret here. We ran this code, and let's say we've deleted that cell since then. It doesn't matter. We can, all of the commands that you run in there are written to a SQLite database. And so here I'm using the default profile. And so if I were operating on this host, I could dump that SQLite history and look for AKIA, which is what AWS secret keys start with. And here, we see that that cell has been run a bunch of times, and here's a secret key that we could now use to do whatever that key is authorized to do in the AWS environment. There are also a bunch of different ways to run startup scripts. So let's restart this kernel. Let's say our kernel froze. We're going to restart it. Okay, that's weird. That didn't happen last time. The reason that happened is because there are startup scripts. So this script here was just about opening that link. And if you read this README, it explains how startup scripts work. But this is another way that attackers can get a code execution workflow on your machine. So the way you might think about that is, let's say I'm on your machine today, and I want to make sure that whenever you open JupyterLab, your machine calls back and connects to mine. And maybe it exfiltrates the models you've been working on or any updated keys. Well, I could write that as a Python file and put it in that directory. How many of us can say that we, audit that directory? I think very few. And so now every time you open it, it doesn't need to open a browser like that example did. It could just be what we call exfiltrating data. And then let's see. So we restarted this kernel, I believe, right? So this should be one now. So let's rerun some of these cells. 2, 3, 4, 5, 6, 7, 8, 9. This kind of history counter thing I think is like a really great feature. 10, 11. Now the trivia question is, what bucket did we just save this pickle to? And if we, look up here for bucket, we see that we probably saved it to this S3 directory, or that's what we intended to save it to. But in fact, we saved it to some other bucket, some weird, this string exists nowhere in this file. Right, it's just that one spot. So how did that happen? Well, it turns out that with the right information, you can send commands to the back end and modify runtime. And so we'll do here. So between originally setting that script and writing to the bucket later on, we ran this, where we used Jupyter client and we pulled the authorization configs out of this runtime directory. And in that runtime directory, there are a bunch of JSONs that control all of the configurations for your kernel. And so once we loaded this connection and started a channel, we could execute some code. In this case, we changed the variable bucket to be this string. And then kind of the powerful capability here is that it accepts this silent argument. And the silent argument is what prevented this number from incrementing. So if we look through here, there's no sign in this notebook that we made this modification. If you had left that silent equals true off, we would see an increment here. We would have seen a jump between some of these numbers whenever we ran that code. So what should you do as you're kind of operating every day? Remember, keep in mind that anything an attacker can do in a terminal, they can do through your instance. So because the tool is so powerful. So the bottom line is to have a defense in depth, read the config, optimize the config for your environment. Make sure you're launching it with low privilege, specific or well scoped down directories. Separate users if you can, which improves your ability to audit the environment. And I think, if you're in a big enough enterprise, you should probably be looking at Jupyter Hub to do a lot of this, because I don't think JupyterLab supports kind of like role-based access control or very granular controls. Enable passwords if you can. Maybe shorten the duration of the cookie from 30 days if that's something that you can do. Know what you're loading and importing. So here I'm specifically talking about pickles. So maybe use a more safe file type or use hashes and signatures so that you're not doing kind of this untrusted behavior. Use a secrets manager so that you're not entering plain text credentials that are getting saved to your history. And then do some network level segmentation. So once an attacker kind of is in Jupyter, they have a lot of power, right? Because this is a powerful tool that you're using. And so, do things like only open it up to your local host, or firewall yourself off however you can. And so, be safe out there. Let me know if you have any cool security tricks or questions. And with that concludes my presentation. I'll take any questions. I don't see any questions. I don't know if there's a host who's controlling that or can help me out.
Yeah, there is one question. Are there any additional readings you recommend?
Well, I'll say that all the material for this and kind of my discovery of these techniques, to what extent it is discovery, came from reading Jupyter and IPython documentation. I think the documentation is really great. And so if you're looking for ways to improve the security of your environment, that's where I'd point you.
Okay, thank you. There aren't more questions yet. So. Okay, there aren't any questions coming, so would you like to wrap up?
Yeah, sure. I'll be available in the Discord or on any social media if you want to chat about it further. Thanks for attending and enjoy the rest of the con.